Welcome to This Explainer. If you're focused on understanding the actual mechanics driving today's massive technological leaps, well, you are in exactly the right place. Today, we're unpacking something truly fascinating: supercomputing for AI, and specifically, the evolution of GPU power. We're going to look at how a totally unlikely piece of hardware, seriously, something you probably have sitting in your living room right now, unexpectedly revolutionized modern supercomputing and became the absolute backbone of artificial intelligence. It's a brilliant story of technological repurposing, so let's jump right in. So did you know that GPUs, graphics processing units, were originally built purely for gaming, but now they literally fuel generative AI? I mean, it's basically the ultimate Trojan horse of the tech world. Think about it. The exact same engine that was designed to render explosions and high-definition landscapes in your favorite video game consoles is now the core engine driving the entire global AI revolution. It sounds almost like science fiction, right? But the architecture you need to put 1,000,000 pixels on a screen at exactly the same time just so happens to be exactly what you need to make machines think. All right, let's dive into this. Section 1, From Gaming to AI. Drawing on insights from Anand Vemula's Tech Horizon breakdown, let's trace this incredible journey. You know, when we talk about AI, the software and the algorithms usually get all the glory. But as Lauren McHugh-Oland expertly points out, it is actually the AI hardware that drives the innovation. This is her core thesis, and it's absolutely vital to understand. The rapid, jaw-dropping evolution we're seeing right now in machine learning, it isn't just because our code got smarter overnight. No, it's because our hardware finally caught up to the math. We built a foundation of silicon that could suddenly handle the massive, almost unimaginable workloads that machine learning requires. Without this hardware evolution, modern AI would still just be stuck in a theoretical textbook somewhere.
And that sets us up perfectly to examine the great hardware divide in Section 2, why GPUs outperform CPUs.
The core of this debate really comes down to the CPU versus the GPU. Your central processing unit, the CPU, is the baseline. It's kind of like the manager of your computer. It's capable of doing a few very complex tasks incredibly fast, one at a time. But as Olinda explains, when we shift over to machine learning tasks, that CPU hits a wall. The GPU, on the other hand, heavily outperforms the CPU here. And why is that? Well, because AI doesn't need a manager doing one complex task. It needs an army doing millions of tiny, simple tasks all at the exact same moment. A standard processor just isn't built for that kind of traffic jam. So the crucial mechanism making all of this possible is parallel processing. This is the definition you really need to lock in. It's the ability to handle multiple calculations simultaneously. Think back to those video games for a second. To render a 3D world, the computer has to calculate the lighting, the shadow, and the color of millions of individual pixels on your screen all at once, 60 times a second. That is parallel processing in action. And when data scientists realized they could use that exact same parallel processing power not just for pixels, but for massive machine learning datasets, it gave GPUs a massive advantage over CPUs. It was literally the eureka moment that changed supercomputing forever. Which brings us to how this actually looks in the real world. Section 3, Fueling Large Language Models. So what does this supercomputing foundation actually achieve? The core GPU benefits for AI come down to a really powerful combination. First, you've got faster memory bandwidth, meaning the GPU can ingest and access absolute mountains of data without choking. Combine that faster memory with the parallel processing we just talked about, and suddenly you are enabling large-scale models. I'm talking about large language models, or LLMs, the massive generative AI tools that are completely reshaping industries right now. These LLMs require billions, sometimes trillions, of parameters to function. A CPU would take lifetimes to train them, but a GPU network, it can knock it out in weeks or even days. The hardware is literally the fuel for these massive models. All right, let's talk about you. Section 4. Accelerate your AI projects. Let's translate this hardware revolution into some actionable steps for your own work. The reality of this industry is that AI hardware and machine learning techniques move incredibly fast. I mean, what was cutting-edge supercomputing 6 months ago is practically standard today. So to keep your own projects relevant, you simply can't rely on static information. That is why staying actively informed is so critical. A highly recommended resource for this is signing up for IBM's monthly AI newsletter. It basically curates the important updates so you don't have to, ensuring you're always tracking the pulse of exactly where this technology is heading next. And taking action goes beyond just reading the news, right?
If you're ready to actually prove your expertise in this rapidly evolving space, you can get 20% off your Watson X Data Scientist certification exam. All you need to do is use the code IBM Tech YT20 when you register. Again, that code is IBM Tech YT20 for 20% off. Earning that certification is just a brilliant way to solidify your place in this AI-driven future. As we wrap up this explainer, I really want to leave you with this one summary thought. AI hardware drives innovation, and it matters for your projects. We've seen how gaming chips literally transformed into supercomputers, and how parallel processing unlocked the massive language models that are changing our world. The hardware is the canvas, and the AI is the art. So, as you step back into your day, I want you to ask yourself, knowing the sheer power and ongoing evolution of these GPUs, how are you going to leverage this supercomputing foundation to build something groundbreaking in your own work? Thanks for tuning in today, and keep building the future.